Of course, what you guys probably care the most about is how graphing works on Hawks, and that does not hurt my feelings that maybe you don't care so much about how to do it with transformations, but I do want to illustrate that these are working exactly the same. Now, when I do it in Hawks, depending on how the function looks, I might think of it in terms of the transformations, or I might do something a little bit different. So let me go ahead and show you what I mean by that. So here is my Hawks. Let's look at 7-1. Okay. So which of the four graphs is correct? I've got 5 halves to the x. So I know that this doesn't have any transformations on it. It's just something to the x. So my anchor points would be 0, 1, 1, 5 halves, -1, 2/5. So the graph, the correct graph, has to have the point 0, 1 on it. So it can't be this one, and it can't be this one. It can't be these two. It has to be one of these. If it has the point 1, 5 halves and -1, 2/5, that means it's getting smaller at the x direction, negative x direction, and larger in the positive x direction, meaning it has to be this one, right? So this point, so 5 halves is 2.5, right? 1, 2.5. Done. So it has to be this one. Okay. Now a bunch of them look pretty much like that. Okay, here's 1/4 to the -x. So I can do my transformations on it, or I can remember negative powers make reciprocals. So what's the reciprocal of 1/4? It's +4. So it has to have the point 0, 1, which means it's either this one or this one. And if it's 4 to the x, it has to get larger as x gets larger. So it's the third one. All right, here's one with actual transformations. So 2 to the x -4. Now another way you can do this is pick an x value and plug it in, right? So 4. 4 is very easy. If x equals 4, then I have 2 to the 4 -4, which is 0. So I get 1, right? So in goes 4, out comes 1, which means it's only this one, right? This is the only one that contains the point 4, 1. The only one. So I'm done. I know immediately that that's the right answer. So kind of depending on how complicated the function looks, this is another one that probably I would just pick points on. So if x were 2, again, I would get 1 as my y value. So I need the point 2, 1. This one doesn't have 2, 1. This one doesn't have 2, 1. This one does, so it has to be this one. This one doesn't. It has 1, 1, so it has to be this. If there's one if there's one problem you do where more than one of the functions has the correct point, then just pick another point that they differ on. That is, I think, probably the easiest way to graph the problems in Hawks. But remember, you can always think of it as transformations if you like the transformations. So on an exam, like on your work, what am I looking for? Either listing the transformations just like we did in the notes, or, you know, write me a sentence explaining x equals 1 means y equals blah, 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 so must contain this point, etc., right? So either one of those I would accept as sufficient work.